Okay, we'll start our lecture. Source of error. If you cannot hear me clearly, let me know. If you need me to use the mic. Is it clear? Okay. Just leave it as is this. Okay. Okay, why we need to know the error? Mouse. Okay, why we need to know the error? Because to reduce the discrepancy, to reduce the gap of the deviation, previous answer and the latest answer. Okay, we want to reduce the error so that we can get the most accurate answer, accurate and precise answer. Okay, there are a few types of error. Just to let you, to introduce you, this one is from Taylor series. Okay, you will see a few more series later on. Okay, this Taylor series is related to FA and then this term. So the terms is expanding. Okay. So as it goes to the right, it is expanding. 2 factorial, 3 factorial, where it will make the answer more precise. Okay, the Maclaurin is when you replace the A with 0. So the original one is Taylor series. Okay. Now you will have few types of Taylor series. You can have sine, cos x, tan x. So there are expansion of equation. Perhaps until infinity. Okay, or you can set at one figure. Okay, this is common Maclaurin. Maclaurin is when the x equals to 0. Now, there are 2 types of error. We have truncation error and round-off error. Okay, truncation error, when you have a Taylor series, for example, like this. Okay, for example, this series, you have first term, okay, second term, third term, and goes up to n term. Okay, this is the first term, second term, third term. Okay, so truncation error. Truncation, what does it mean? The word truncation itself. You truncate. What is truncate? What is it? Are you here or are you still dreaming? I know it's 8 a.m. class. Truncate, you cut it. Cut, okay? So, truncate error is when, let's say you cut the equation up to third term. the third term over here, for example. So you just use first, second, and third. In comparison, if you use up to n term, you will have some errors. Okay, and the value is a bit different. Okay, the one is truncation error, which is refers as method error. Okay, whereby the round off error is the machine error. Round off error always like, for example, pi value 3 point what? 142, 1416. So you round off to 142, right? So if you find the error between 3.1416 and 3.142, there's a slight error over there. Okay, that is round off error. Okay, we look for this one. Let's say exponent 1. From calculator is always the true value. Okay, in your calculation, you will need to find true value first in order for you to compare the error with the calculation error. Okay, so from the calculator, exponent 1, is it correct, this value? Try to press. Right, 2.71828. 1828. Okay, the full one. So let's say I take up to 5 decimal point, 71828. So that is considered as the true value from the calculator. Okay, but from the equation we have over here, using this equation, okay, using all this equation, using all this equation, the first term E1 equals to 1, correct? If you use only first term, right? So in comparison with the true value, there's a difference. Okay, so that's the error. You get now what I mean? E1, the first term, you only use EX equals to 1, first term. Okay, EX equals to 1, the first term. So equals to 1 lah. This is the value whereby your true value from the calculator is this one. Okay, so there's error over there. When you include the second term, which is EX equals to 1 plus X, this one, E1 equals to 1 plus X. X here replace with 1. So you will have 2 equals to 2. Okay. Then expand, include the third term where X power of 2 over factorial 2. Okay. So when you expand, you will have 2.5. It is approaching the true value. Okay, so you add more the fourth term, you will have this figure. Fourth term. Fifth term, approaching the true value already. Okay, so from the Taylor series over here, the more terms that you use, the lowest error from the true value. Okay, understand the concept? Yeah, so if you use until n order, n term, you will get a very small error. Okay, you will reduce your error. Now we have true error and approximation error. True error is using true value minus approximation value. Approximation value here is from the equation, the term that you use. Divide by true value, whereby the approximation error is the current approximate value minus previous approximate value divided by the current approximate value. Okay, so from the previous value, the one that you get using term from term 1 up to term 5. Okay, inclusive up to term 5. You will have various of value. 1, 2, 2.5. Okay, we collect them into the table over here. Inclusive of term 1, approximate value is this. Okay, this is from the calculation, the equation, approximate value. True value is from the calculator just now. Okay, so the EA for 1, EA for term 1, EA is approximate value. Term 1, it should has current. Current refers to the one over here. Minus previous approximate value. Is there any previous approximate value? No, right? Okay, so for term 1, there is no EA. Okay, for term 2, you will have this. Okay, wait, just let me do the new slide so that easy for you to understand. Okay, for the EA, approximate value for the first term, there is none, 0. EA for second term. Okay, EA for second term. A current approximate value, which is 2, minus previous, which is 1, over current, over 2. What you get? 0.5%. Okay, so you put it here, 0.5. This is in percent value. Sorry? 50%, Oh yeah, correct, sorry. So 0.5 is this. So in percent should be 50% lah, correct. Multiply 100. So 50%. So the error now is 50%. approximate value. Okay, approximate error. How about the true error? The true error is from the true value. The true value just now is 2.71828. Okay, so the true value minus approximate value. Now we are looking at second term. So 2 is your approximate value over the true value. Multiply by 100. What do you get? 36. 20. 26. So here 26%. Okay, try to find for the third term, fourth and fifth for EA and ET. True value and approximate, true error and approximate error. What do you get? Okay, try to find out. Are you familiar with the factorial term? Factorial. Do you guys familiar? This one. 3 exclamation, 4 exclamation. Familiar? So you know how to use in your calculator. Okay. Do you know which button to press for the factorial? You can just use directly from the calculator. You don't need to expand. Okay, it should be shift logic over there. The word logic, next to the word logic. Right, for true error, for the first value, you will have value. Because we are using true value, not the approximate value. Okay, so here you will have value. So for the ET1, it should be true value minus the approximate value, which is 1. What you get for the first one, true value? 63. Okay, EA, for the third term, what you get? 3 point. $25. Wait. Oh, yeah, correct. EA for the fourth term, what you get? 6.25. Okay. This one 1.54. Okay. So you can see they are decreasing. The EA value decreasing. EA error, sorry. Approximation error is decreasing by expanding the term. Okay. True value for the last term 0.37, correct? Okay, so it is approaching the true value. So as you expand the term, you will have the value approaching the true value. Okay. Okay, this is similar to the explanation. You can read through. The equation that I introduced earlier, the true percent of relative error, okay, where it used the true value. Okay, this is the approximate error. Make sure you know the difference. True error and approximate error. Approximate error, it use the approximation value. Okay, true error, it use the true value. Okay, there are two different error. Okay, when we have EA, approximate error, and ET, true error. Now, here we have a pre-specified tolerance of error where you already set at until how many percent of error that you need. From the calculation just now, until fifth term, the EA value you get is 1 point something, right? True error is 0.3 something. Okay, so you do not know when should you stop, until what error, what percentage of error. The question haven't set anything. Okay, sometimes the question will set your calculation must be in between the ES. So your EA must be below the ES, specified error. So how to determine the ES is based on this equation. Okay, this is fixed equation. 0.5 multiplied by 10 power 2 minus n. N here is the significant figure. Significant figure. Okay, so let's say you are given, you need to find the E A and at least n significant figure. For example, n is equals to 4. What is significant figure? Is it the same as decimal point? No. What is significant figure? Correct. How many number? So let's say 2 point just now 78128. How many significant figure over here? 6, right? So let's say the question asks you to find out. Let's say it gives you n equals to 4. So plug in number 4 in here. 2 minus 4, 0.5 with 4 significant figure. What do you get for your ES over here? In percent. 0.5. Same? Okay, 0.5. So from the EA that you calculate earlier, for example, we use the previous example, EA, your EA should be lesser than 0.5. Then only you can stop. Okay, so this ES is a guidance for you when you should stop your calculation. It's either they will give you the ES value or significant figure, or it already mentioned to you stop until 5 iteration. Okay, it will guide you when you should stop. Okay, get it over here? Anyone need me to repeat? It is not limited to EA only. ET also apply. ET, true error. Okay, later we will have exercise for that. Okay, this example is the same as we did previously. The same Taylor series. Okay, but now it asks to calculate until EA lesser than ES. Okay, first iteration is using the first term. Second iteration inclusive the second term. Okay, and so on. Okay, this example, it used E 0.5. Just now we did E equals to 1. Sorry, E1. X is 1. Okay. Initial is EX. So X over here, this one equals 0.5. Similar as we did just now. Here it gives carry out the calculation until the absolute value of the approximate relative error, which is the EA, falls below an error criterion conforming to 4 significant figures. So by using these 4 significant figures, plug into the ES equation, okay, just now. When n equals to 4, you will get 0.5. Okay, so proceed the calculation until EA is lesser than 0.5. Understand? The requirement. Okay. Now we will not proceed for this example. Later we do one exercise. Here I will explain. Okay, so from the true value, when you press your calculator, E 0.5, you will get this figure. Okay, so for the ES, 0, this is the value for 4 significant figure, not 0.5. So stop iteration when EA is lesser than 0.0.5. Okay, so this is the example. It shows in the table for the first, second, up to iteration until EA less than 0.5. At the fifth iteration, this is the error. Okay, this is the EA value. This is the ET value. Okay, but the question wants below 0.005. So you should, do you need to proceed the calculation? Why you say no? Because EA is 0 already. How about ET? The question mentioned EA, right? EA, but now EA is only 0, not 0.05. Okay, so you should know when you should stop. Sometimes you will have until 6 or 7 iteration until you meet the requirement. Okay, now we do try this exercise. Similar Taylor series, but now X is 1.2. Okay, the question asks you to calculate the values for E 1.2 by using truncated infinite series with an absolute relative approximate error less than 1%. So here it already gives you the ES. ES here is 1%. So your EA, approximate error, EA, should be less than 1%. Okay, you should also compare your result with true value. Okay, try first. First thing, you will need to find out what is the true value. True value for E 1.2. Then from there, proceed with the approximate value. Okay, try first. Here it mentioned EA must be less than 1%. So once you get the final value of the EA, the final iteration, then only you compare with true value. You calculate the ET. For the ET, you don't need to calculate for each iteration. You get what I mean? Focus on the EA first. The true value, the true error might differ depending to your decimal point that you use. Since this question, it doesn't mention up to what significant figures. So if you use lesser decimal point, lesser significant figures, you will get different true error. Just now, some of your friends at the back got 0.15%. Okay, you guys in front get smaller. There's a smaller percentage for true value. True error, right? So it depends on your decimal point and significant figures. So that is the example of round of error. Okay, can Any question before we stop on the error? Okay, you can try to do some exercise from the CN. Are you all in the CN? Okay, there are a few exercises listed, so you can try. Okay, so that's all for today. Thank you.